transposition. So I know a lot of you have been asking questions about transposing and stuff like that, and I know this is one hurdle you need to cross over before you actually try to do anything in the physics area of things. If you have no idea how to transpose, you're pretty much lost. The only thing you could probably do in physics is probably read. So here goes. We can try some transposition and we can have some fun with the four equations of motion. So we have velocity is equal, so final velocity is equal to initial velocity plus acceleration, which times time. The second one is where we have final velocity squared equal to initial velocity squared plus 2 times acceleration times height or distance. 3 is distance or height, which is equal to u plus v all multiplied by t over 2. And then we have the last one, which is also distance or height, which is equal to the initial velocity times time plus a half a and entire t squared. Okay, so here we have an example with v equals to u plus at, and we want to solve for a. So basically, if you have v equals to u plus at, we try to get rid of u first. So we say v minus u, and whatever you do to one side, you do to the next side, u minus u plus at. This cancels out, and we're left with v minus u. So v minus u will be equal to at. Now we're still solving for a, so we want a to be over here, and the easiest thing to do since it's multiplied, divide this side by t. And whatever you do to one side, you do to the next side. You divide that side by t. And all cancelled out, we have v equals to u over t equals to a. Pretty easy. Now let's solve for t. T should be just as easy as a because it's the same concept we're going to use. So we're going to do the same. V minus u equals to u minus u plus at. So we're going to have now v minus u equals to at. And this time, instead of dividing by 2, we're going to divide by a and divide by a. And now we're going to be left back with v minus u over a equals t. Cool. Now you be cool as well, because now we want to find just this here. So we're going to say v is equal to u plus at. I just felt like writing out the whole thing. And we're looking for this. Since we have a plus here and it's all multiplied, so we could treat this as one number, because it's just 3 times 2, it would be 6, right? So we could say v minus at is equal to u. And that's pretty much it for this one. Cool. Now we have s is equal to ut plus a half at squared, and we want to solve for u. This is much more difficult, and we could treat it just like how we treated the last one. We could treat these two as whole entities, right? And we could, since we're looking for u, we could treat this as an entire entity on its own, because if this was a half 10 times 2 squared, so 2 times 2 will be 4, you have 40, and 40 divided by 2 will be 20. You have ut plus 20, so you could treat this as a whole entity and say s minus a, let's put in brackets, a t squared over 2, and why I put all over 2, because it is multiplied throughout by a half, equals to ut. And since we just left back with ut, we just divide by t here and divide by t here. This cancels out, and we have s minus at squared over 2. And of course, you're going to work your brackets out first. All divided by t equals to u. Cool. And now we're going to try to solve for a. And this is a little bit more tedious because the whole entity that we dealt with first will now have to be broken apart. So we have here, we could write it all out as equals to ut plus the same thing I did before with at squared over 2, right? So from there, since we're looking for a, we could get rid of ut first. Whole entity again. We could say s minus ut equals to at squared over 2. Therefore, we could have 2 bracket s minus ut equals to yes, I'll show you how I do it, at squared. And now we could say a, we're going to divide this side by t squared, because we're looking for a, and we're going to divide this side by t squared. So now we know that 2s minus ut all over t squared is equal to a. So that wasn't so hard, but you had to have some idea and knowledge of how to do these things beforehand. This is my weird assumption, and I hope that you have had a little bit of knowledge of transposition. You could also check my other videos on transposition as well. Now this is the hardest yet, we're solving for t. Now, you already have 3 t's because you have the squared and you have that extra t right there. So we have s is equal to ut plus a half at squared. To make things easier, I would write out ut plus a t squared over 2. Um, and I would, since this is a t squared over 2, I will multiply this side by 2. I will put this all over 1 to get this to be together. So we have now s is equal to, as it times 2, and this times 2. So you have 2 ut plus at squared all over 2. And since we want t now, we could say, oh, you have a t here and a t here, cool. So we're gonna take it out and put t out here. So tu 2u plus at over 2. So now we can say times 2 here and times 2 here. So we're going to have 2s equals to t 2u plus at, all in brackets. This cancels out and this cancels out. So now we have 2s equals to, and we're going to divide this side by 2u plus at, and we're going to also do the same thing here, 2u plus at. This goes and this goes. So we have 2s over 2u plus at equals to t. And that's basically it for this one. Now we have v squared equals to u squared plus 2as. And we want to solve for u. So we're going to say v squared minus 2as is equals to 2u squared plus 2as minus 2as. These go. And now you're left back with v squared minus 2as equals to u squared. To get rid of this squared, you multiply by that, and you multiply this entire thing by a half as well. This half is actually a square root sign. So everything on this side is squared. So it's going to be v squared minus 2as equals to this goes and this goes. So you're left back with u. Basic. Now we want to solve for s. So we're going to say v squared minus u squared is equal to u squared minus u squared plus 2as. This goes. So that's a v squared minus u squared equals to 2as.